Welcome back. Let us look at polygons. Now, a polygon is basically a closed figure, right? It's bounded by straight lines. Now, we're going to look at the various types of polygon and some of the properties, right? Now, the minimum size you need to have a polygon is 3. Now, when you have 3 sides like this, we of course call it a triangle. Since you have 3 sides, you will have 3 angles as well. So this is our triangle. So that's 3 sides and 3 angles. Then you have the quadrilateral. For example, this. 4 sides, 4 angles, right? So that's a quadrilateral, 4 sides and 4 angles. Then you have those with 5 sides and 5 angles. One, 2, 3, 4, 5 sides, and the number of angles is always equal to the number of sides. And when I say angles, I'm talking about the interior angles, right? This one is called a pentagon. Pentagon, pentagon. You have those with 6 sides. Let me draw it properly. 1, 2, 3, 4, 5, 6. 6 sides. And this is the hexagon. Right? The hexagon has 6 sides and of course 6 angles. Then you have the heptagon, 7 sides. You have the octagon, 8 sides. The nonagon, 9 sides. The hexagon, 10 sides. Right? But I want you to draw those yourself. Right? That's your homework. To draw the one with 7 sides, 8, 9, and 10. Now, we have a type of polygon that has one of the inside angles greater than 180. For example, it might look like this. You have this inside angle, this one, this one, this one, and this one. All of those are less than 180. But this one is greater than 180 degrees, right? It is called a re-entrant polygon. You write that down. It's a re-entrant polygon. Once it's not a re-entrant polygon, then none of the inside angles is greater than 180. And sometimes they are called the convex polygons, like all the others that we're looking at here, convex polygons. Now, you have the regular polygon and the irregular polygon. A regular polygon is one which has all the sides equal in length. And of course, all the angles will be equal in length as well, right? The irregular polygon will not have that. For example, if this side of this pentagon is shorter than this side, then this is not a regular polygon. But if I tried to make all sides equal in length, it is regular. It would be a regular polygon, right? Now, the sum of the exterior angles is always 360 degrees. By exterior angles, what I'm talking about is a situation where I extend this side and I form an angle outside here. That's an exterior angle. If I extend, let me do that again. If I extend this and I form an angle out here, that's exterior. That's an exterior angle. I could extend this too and form an angle here. That's an exterior angle. I can extend this side and form an angle outside here. That's an exterior angle. All right. Now all the exterior angles add up to 360 degrees, and it doesn't matter how many sides the polygon has. Let us say, for example, we have a pentagon. Let's draw a pentagon somewhere here. So we have 1, 2, 3, 4, 5 sides. Let's extend this, this, and this. So we have one extension of each side, right? Let's make one angle at each extension. Exterior, 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 exterior. So we have an exterior angle on each of the sides. It means this angle, this plus this plus this plus this plus this, all 5 angles will add up to 360 degrees. All right? Now, another property of these polygons is that the interior contains 180 times n minus 2. Therefore, you can say they contain n minus 2 straight angles. Right? They contain n minus 2 straight angles. Shouldn't have the 180 degrees the same as straight angles, so I was just repeating myself there. Now, it means that you have a formula. You have a formula that you can use to calculate the total angles inside. So, let me write down this formula. So, the total interior angles equal, or the sum, INTERIOR, the sum, a better way to put it. The sum of interior angles equals 180 n minus 2, where of course n means the number of sides. N is the number of sides. Now, let's look at each in turn. Suppose we have a triangle. The number of sides is 3. So the angles, let's use this symbol for angles, the total interior angles. Let's say S angle, the sum of the angles equal, I'm just using this little symbol for angles. Some books, they use this instead of writing out ANGLE. Alright? The sum of the angles is 180 times n, which is 3, minus 2. 180 times 3 minus 2. 180 times 2, which is, no, 3 minus 2 is 1, not 2. 180 times 1, which is 180. So the interior angles add up to 180 degrees. Let's try that again with a quadrilateral and see what would happen. N is 4. The number of sides is 4. So the sum of the angles is 180 times n, which is 4, minus 2. So it's 180 by 2, which is 360 degrees. So all 4 add up to 360. All 4 interior angles add up to 360. For the quadrilateral, just like with the triangle, all 3 add up to 180. Now let us try it with a 4-sided figure. Remember what the 5-sided figure I mean. Remember what the name of the 5-sided figure is? It's a pentagon. You have in the USA that building that they call the Pentagon. It's shaped like a pentagon, so they call it the Pentagon. It's a government building, right, in the US. Now, here, this is a pentagon. Question is, this plus this plus this plus this plus this angle, how much do they add up to? Let's see. The number of sides is 5. The sum of the angles, interior angles, is 180 times n minus 2, which is 5 minus 2. That's 180 times 3. What's 180 times 3? Let's try it out. 300. 3 is 24. Bring down the 4. That's 2. 3 1 3. 4 5. And 2 5. So it is 540 degrees. So for 5 sides, it's 540 degrees. Alright? Let's try with a 6-sided figure. That's hexagon. 6 sides. 1, 2, 3, 4, 5, 6. Now, what is the sum of this angle plus 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 this angle? What is the sum of all these 6 angles? We know that the number of sides and the number of angles is 6. So the sum of the interior angles is 180. 6 minus 2. That's 180 by 4. Right? Now, let's multiply that out. 180 by 4. 180 by 4 is the same as 180 by 2 by 2. And I remember that 180 by 2 is 360 from what we did before. So it's 360 by 2. What is 360 by 2? 360 by 2 is 2002612. Bring down the 2. Carry 1 3 2 6 2 3 6 and 1 7. 720 degrees. So all of these 6 interior angles add up to 720 degrees. So you see here that the interior angles of a polygon is it has n minus 2 straight angles, and this straight angle is 180. So you can calculate it by saying 180 times n minus 2. So you multiply 180 by 2 less than the number of sides, right? So 180 n minus 2 is a formula for calculating the sum of the interior angles of the polygon. I'll see you in the next video.